All right, so it's a great honor to be here and present our recent works. And here's the list of my collaborators. I realized very few people talked about a higher dimension except Marino, Marcos Marino. Sure. Much higher. Too high, so unfathomable. So let me start with Spenta's. I noticed his thesis, even though he didn't have paper, had application to monopoles and instantons. And today's talk will have something to do with instantons. So I'm happy to come back. He left the field and he thought it's garbage, but still there are something to dwell on. Other thing is, I read about Spenta's stories and realized that he was in international house for a year. And I spent a year in 82. 83, and I missed him. He left New York to conquer the bigger world, but I was just arriving. So, so I shared some of the old histories. So let me start with four-dimensional field series. There are many classes of four-dimensional field series, among which there's 4D Yang-Mills series, which is asymptotically free, which means in UV high-energy regime series, weakly coupling, and IR in low energy or long distance interaction is strong. Now, there's another theory, QED, which is completely acting differently, which is that in UV region, it is acting strongly, and also it's not even well defined. It has a Landau pole. The singular coupling blows up in finite momentum. On the other hand, in IR, it's interacting freely. And then there are conformal field series where coupling is constant and so on. But so let's try to go beyond the 4 dimensions. And we are trying to write down, say, 5D and 6D Yang-Mills series and try to see what kind of theory we have. If we write down the Yang-Mills theory, then action tells us that inverse coupling constant has mass dimensions, mass square, which means that if we expand in coupling constant, then it's the inverse of the mass or inverse of mass square expansion, which means it's acting like effective action. So theory has obviously cut off at the length scale given in terms of inverse of coupling constant. This theory, because 5 or 6 dimensional space has bigger space than 4 dimensions, IR is free, but in the length scale shorter than 1/m, theory is interacting strongly. But because of this expansion, so this theory is Yang-Mills action is basically effective action, and coupling constant has one of mass dimension. So it looks like a non-renormalizable, and theory doesn't make sense. So question is precise phi cubic theory in 6 dimensions, which we know is asymptotic free, which we all learned from the Ramanujan's book, but is not bounded below. Besides that, one can ask whether there is well-defined quantum field theory in higher dimensions, especially 5 or 6. In 5 dimensions, Cyborg answered the question about 10 years ago. He said that if I have n equal 1 supersymmetric Yang-Mills theory with SU2 gauge group and n fundamental hypermultiplets, then this theory can have a UV fixed point. What it means is that theory looks like if I find a coupling constant and short distance is strongly interacting, long distance is interacting weakly, but I can make a coupling constant to go to infinite. Then strong coupling regime covers all the space-time regions. In this case, theory becomes conformal symmetric theory, and especially he claims that flavor symmetry, which for SU2 is SP1, so it has SO2n flavor symmetry. And then there's additional U1 symmetry comes from instanton numbers. There's instanton solitons, which is BPS. And because the instanton number is conserved, one can give a corresponding U1 symmetries. And then these two symmetries merge together into a larger group, which is exceptional group of m+1. So he gave a rough field theoretic argument, then he gave some stringy argument. Then, so one can have a flavor from, say, because we know there's only EA symmetry, so from 0 flavor to 7 flavors. Now, Morrison and Seiberg proposed an extension of this. For 0 flavors, one can have either, you can have SP1 theory, can have theta terms with 0 or pi. Now, with higher flavors, they're equivalent. And there are two types of enhanced symmetries depending on the theta terms. And also they suggest that there is a theory, non-Lagrangian theory of rank 1 without any global symmetries. And so if you look at the exceptional groups, then of course we know E6, E7, E8, but as you reduce the flavors, we get to the SU5, SO10, and then, for example, with single flavor, with no flavor, say n equals to 0, one can have theta equal to 0, then we have SU2 symmetry instead of U1 symmetry coming from instantons. So there's enhancement of global symmetries. And then there is theta equal to pi case, we have U1 global symmetry just coming from instantons. And then this E0 theory doesn't have any global symmetry. So those are a list of the theories he has proposed. And also he proposed that if we have 8 flavors, then instead of gauge group is E8, we have a 6-dimensional theory completion, not 5-dimensional conformal symmetric theory completion. And in this case, one ends up with 61,0 superconformal free theory with E8 global symmetry. So that's what he has proposed. Now,
higher than that, the theories are unstable. What happens?
Or if you go, you can make 16 flavors, for example, then it becomes a leader string theory. So it's not quantum field theory anymore. So as you go beyond the 8, it becomes some sort of a stringy theory. Now, 61,0 theory, again, Seiberg did work about 10 years ago, 20 years ago. Wow. He said that, again, there can be non-trivial fixed point. And in 60, one can have various supersymmetries, 1,0 or 1,1, 2,0. And the 1,0 has 8 supersymmetries. And one can have vector, hyper, and not like 5D or less dimensions, one can have tensor multiplet in 60. From tensor field whose field strength is self-dual. And then here is helicity. So theories are pretty much chiral theories. And so if we think about vector multiplet coupled to hypermultiplet, or just theory with vector multiplet itself will be anomalous because gauge inner field is chiral. So one has to solve the anomaly constraint, and there's more reason to work on this subject. Anomaly constraint can be explored by looking at anomaly polynomial, and the contribution from a meta field can be written in terms of represented in terms of fundamental representation, and then there's 2 combinations. And so if we have various hypermultiplets and the vector multiplets, this term has to be canceled by its own. On the other hand, this second term, as long as this remains the positive definite, then one can use this Green-Shibarish mechanism to cancel this anomaly. What it means is that you couple this tensor multiplet to gauge field through this coupling, and then one can cancel the anomalies. So one can have anomaly 1,0 theories where usually vector is coupled to tensor in this manner, and then hypermultiplet is coupled to vector. And there's a whole classification of these theories done recently. Now one can think about maximally supersymmetric 6D conformal field theories or quantum field theories. And there are 2 kinds of maximal supersymmetric theories. One is 2,0 theory, which ends up being completed by superconformal field theories. This work is done a little earlier by Witten and Andy and Igor and Zetlin, where they are looking at the physics on M5 branes, or type 2B string theory on ADE singularities. In which case, one can have 60 2,0 conformal field theory. If there's an abelian case, that 3-form tensor field whose field strength is self-dual, and then we have a fermionic field which is chiral, and there are 2 of them, that's why it's 2,0, and then there are 5 scalar field which tells, for example, position of M5 branes on transpose directions. And the M2 branes connecting to M5 branes act as a self-dual string, source of this 3-form tensor field, and also because this tensor field is self-dual, which means that this string should be self-dual. In some sense, it carries both electric and magnetic charges. So that's why this two-comma theory is sometimes called quantum theory, because there is no adjustable coupling constant. Now, there are different kinds of 6D theory, which I will not talk much about today, which is called the little string theory. So let's think about, say, 6D maximally supersymmetric Yang-Mills theories and try to complete it. Now, 6D maximally supersymmetric Yang-Mills theory has a coupling constant, and then you have an instanton string, because spatial direction is 5 dimensions instead of 4 dimensions, where we can have instanton particles. So you have an instanton string, which is, of course, self-dual in a way, that because it satisfies self-dual equations. And this theory, Yang-Mills theory, of course, is again non-renormalizable, but Yang-Mills theory with instanton string is some sort of little string theory, which is strongly interacting little string theory, without any gravitons in there in low energy. So this is stringy theory, and there is such completions. Or, for example, if we think about NS5 rings in type 2A, type 2B, and if we look at the fundamental string living on it with the limit where coupling constant string coupling goes to 0, and string tension remains, one ends up with a little string theory. So those are very beautiful theories. Even today, they have a paper applying this for some fancy mathematics. So those are kind of theories we are looking at. But today, I'll look at a very small part of the stories. So I'll look at the generalization of the 5D Seiberg's result of SU2 theory to higher gauge groups, which is rather simple generalization. So remember, Seiberg, when proposed his studies SU2, is number of fundamental flavor from 0 to 8. So can we generalize to SU3 or different gauge groups? So this is the attempt we have done. And this theory's generalization is related to again 60 1,0 super-conformal field series. As in SU2 theory, if we have 8 flavors, then theory goes up to the 6D 1,0 theories. Similarly, this generalization will take such a form that if we put enough matter field, then it will jump into the 6D theories. So some sense, one start from 6D theory, then we remove the flavors, then we end up with new kind of 5-dimensional super-conformal field theories.
So you put the 6D theory on a circle.
Right. And then you go to low energy, then you remove flavors, then you cannot go back to the 6D. So we'll see that there's, again, similarly enhanced global symmetries. And also, there's something, this work is related to Kuppakma-Baffa invariance, which I don't know much about. I've been trying to learn about it. And if I have time, I'll talk about it a little bit. Right, so let's start with 6D 1,0 super-conformal field series. There's a whole classification of it, but let's look at the case with EA global symmetry. And the EA global symmetric 6D 1,0 theory can arise in many, many settings. So simplest case is you start with Hodava-Witten wall with EA global symmetry, then you explore that with M5 rings, then that dimensional reduction is SU2 is 8 flavors. Where SO16 symmetry is obvious, but EA symmetry is not. But you can recover it by going to strong coupling limit or going back to 6D, then you can recover the EA global symmetries. Or one can have a tensor theory, this tensor multiplet, coupled to E7 and SU2 global symmetry. And this appears as part of E7 conformal methods. You can gauge E7 with tensor, SU2 is tensor, and so on. So this is a chain of the theories, and we just look at the small part of the chain of the theories. Or E6 tensor SU3 theories, or G2 tensor F4 theories. And this case, even the symmetry group rank is smaller than E8, but we are sure that this theory will enhance to E8 global symmetric theories. And then finally, there is a theory with SO8, tensor SO8, which comes from D4 conformal methods, And again, this theory all enhanced to E global symmetry, all these four classes of theories. So to generalize this setting, let's look at this theory, which looks much more less demanding. And one can see, if you look at the T4 plus K conformal methods, which arise in many settings, especially if you look at sixth conformal field series, one can think about M5 brain exploring the T4 plus K conformal singularities, and that setting can be translated into configuration. We have O6 minus with 4 plus N T6 brains. Basically, that's the one which gives you T4 plus K singularity. And then we are introducing one NS5 brains, which gets split into two pieces, fractional pieces, and in middle, number of the T6 brains get reduced, and we get O6 plus. And in middle, one get SPK theories or SPN theories, and outside we get SO2n plus 8 global symmetry coming from these strings connecting this over the NS5 brains. So this theory we'll start with in 60. So this theory is SPK theory, 1,0 theory, coupled to 1,0 tensor multiplet, and then we have a 2K plus 8 fundamental hypermultiplets. So because fundamental representation of SPK is pseudo-real, one can see global symmetry enhanced to SO4K plus 16. Especially if K equal to 0, then this is SO16, which we know that it will get enhanced to E8. But this case, when K is larger than or equal to 1, this will not get enhanced. It will stay as SO4K plus 16. Now one can do 5D reduction, and there are many brain technology, but there are very simple way of looking at it. We wrap the M5 brain on a circle, leaving the deep K plus 4 singularities, then it's just T4 brain exploring TK plus 4 singularities, which we know that theory is given in terms of TK plus 4 type Kubo theories. So if we have single T4 brains exploring this singularity, then there is SU1, SU1, SU2, SU2, SU1, SU1. And SU1 theory in 5D doesn't have any dynamics in there. But one can give a PQ5 brain pictures of this theory, which is basically this one is SU1s, and here is SU2, SU2, SU1 theories. This theory is Kubo theories, but we can T-dual it or S-dual it, which means this T5 brain, this NS5 brains, but by rotating 90 degrees, we are extending NS5 brain, T5 brains, ending up with this PQ5 brain pictures. Now, if you look at these PQ5 brain pictures, then this is SU2 theories, SU3 theory with 10 flavors. So we end up with 5D SU3 K theory with 10 fundamental hypermultiplet. And SP1 case, Chern-Simons level is 0 pi for no flavors, but there's no Chern-Simons levels. But SU3 case, one can turn on the Chern-Simons levels, and this theory has 0 Chern-Simons levels. And now this 5D theory will remain, which let's go back to SU2 is 8 flavors, which I mentioned, which ends up in 60. In that case, SU2 with 8 flavors, SO16 with U1 coming from instantons. And they merge together such that U1 gives KK mode of compactification. Now, similarly, if you look at these theories, this theory has U10 because we have 10 flavors of SU3, global symmetry coming from fundamental matter field. Then we have U1 coming from instanton of the SU3 gauge groups. And we are claiming that this theory has enhanced global symmetry, even though theory looks like a U10 cross U1, it has enhancement to SO20 cross U1 to the KK. There are many arguments for it. Simplest of arguments, which I'm not expert, but my collaborators are all expert on 7-brain dynamics. And one can just pull all these T5 brain or NS5 brains or PQ5 brains ending on it, pull into the this PQ5 brain webs, And so you wrap the 7 branes with the 5 branes and transform it, and then one end up with a simple operation with the one side of it has a T10 7 brane, which has SO20 global symmetry. So from this manipulation, one can see there is a SO20 global symmetries, or one can do the various calculations like instanton calculations, elliptic genus calculations. You do whatever calculation you can do, then you can see there's indeed an enhancement of global symmetry to SO20 cross U1. Wow. So here is the theory we obtained by removing the flavors. As we remove the hypermultiplets, Chern-Simons levels are induced, and global symmetry is number of flavor, rank is number of flavor times the instanton numbers. So those are the sort of graphs which generalize the Seiberg and Seiberg's conjecture. Now you can generalize to arbitrary gauge group, SPN, then SPN minus 1 in 6D becomes SUM plus 1 in 5D, and again you can number of maximal flavor is 2n plus 4, and then you can remove the flavors, and then you get a Chern-Simons terms and induce the enhanced global symmetries. So as we remove it, you can see some of the theories remain to have a SO4n type of global symmetries. So you may wonder what are those theories? And turns out these theories have a dual description in 5D, where which is this I'll skip, conjectured by Guyot and Hitcher-Gim, that not only you can have SUN with a certain number of flavors, Chern-Simons levels, this theory is equivalent to SPN minus 1 with same number of flavors. What it means is that you have a conformal field theory in 5D. You can perturb it Lagrangian using SUN gauge group or SPN minus 1 gauge group. And they give you different description in IR, but UV fixed point is identical. And those theories are basically ones with SO type of flavor symmetries.
Both the theories in duality have this Chern-Simons level?
No, right. So remember, SP theory has no Chern-Simons level. So on the other hand, the SV theory, you have a maximal Chern-Simons level. So those two theories are equivalent. And one can show that using instanton calculations. This brain picture configuration shows that they're equivalent. You can do all kinds of things, and you can see they are genuinely equivalent to each other.
And both theories violate parity just because they're chiral.
Right. In 5D.
Oh, no.
No, yeah.
So it sounds like the first one violates parity, but the second one does not.
No, it's all violates parity. Of course, Chern-Simons levels violate parity.
But what about the SPN?
SP pictures. SP pictures.
You said there was a duality between the SUN with Chern-Simons.
Right, and right.
Without, right?
Right, so parity should be, both should have same parity.
Right, but it looks like the SUN violates it while the SPN does not.
Right, so I'm confused. But right, so one can show two theories are equivalent. And one can show that using, for example, index function of dyonic instantons. But I know I don't have much time for that. Interesting to note about is that, let me, before finish it, zero flavor case, we can have a E1 theory, and we can have W bosons and instantons. They are S-dual to each other. So if you look at Kufakumab-alpha invariant, then leading term you count the hypermultiplet, next leading term count the vector multiplet. And this theory has one matrix vector, but two massive vectors, one coming from W bosons, one coming from instantons. So this is a rather different type of theories. In 4D S-dual theories, we have a matrix vector and a massive W boson, but description changes when we make a S-dual transformation. So I don't know whether these two theory, two instantons and W boson has to count as independent degrees of freedom when we put it into loops or whether it's the single degrees of freedom. Those are very interesting questions. So to conclude, there are a lot of things to learn more about 5D and 6D conformal field theories and little string theories. And one of the hot topic currently is classifying the theory in 5D conformal field theories. Let me just conclude. I wanted the picture of the Spenta, which is most forceful one. And wish you many, many happy returns over the day.
Maybe just yeah. In these three-dimensional matter Chern-Simons theories, if you make the level of you can take fermions coupled to Chern-Simons theory. When the 't Hooft coupling is as large as it can be, it looks like it's maximally parity violating. But then we know that it's dual to a gauge scalar without the Chern-Simons term. So it's actually parity preserving. So maybe the same things happen.
Maybe something like this.
Quantum mechanically parity preserving.
Recently, there's a lot of quantum mechanical preserving time reversal symmetries. So I guess
in these theories also you have the self-dual tensors, right?
No, when I start, yes, but when I go to 5D, it merged into single gauge groups. So.
You were talking about classifying five-dimensional theories. What about the corresponding problem with 6 dimensions?
They claimed it's done, but...
who claims, sorry?
Papa and all these collaborators, atomic classification of the 6D theories.
That's the classification you can get from string theory, right? Is that...
I think it's some sort of F theory, some sort of... Yeah.